makes with the closest side of the x-axis. Okay? All right. So let's see here. Well, we're over here. So our choices are the positive x-axis, which is 0, but that's 135 degrees away, or 180 degrees, which is the negative x-axis over here. Well, we're going to go with 180 degrees, and essentially what we're going to find, we're going to call it our reference angle, and we're going to find this angle over here, okay? Now, to find the reference angle, since I'm choosing the negative x-axis, I am just going to do 180 degrees, which is, since I chose the negative x-axis, you're going to use 0, 180, or a multiple of these angles, minus my actual angle, which is 135 degrees, and well, 180 minus 135, well, 135 and 5 is 140, and another 40 is going to be 180, so this is 45 degrees. Okay. Now, you might be asking, well, I could have, instead of 180, I could have chosen a multiple of 180. That would have worked. Like 180 times 3, for instance, would also be this angle, because I could go 0, 180, 360. 360 and 100 is 460, and 460 and 80. So I could go 0, 180, 360, 540. So why don't I use 540 instead of 180? Well, I want this. I only know angles between 0 and 90, so I want to choose the closest number to this 135, which is going to be 180 here. So I want the difference to be less than 90. So I want this difference here to be less than 90, so I'm going to choose to be 180. And the next thing I'm going to do is I'm going to write my x and y as if my angle were 45 degrees. So I'm going to do write x comma y for the reference angle. I'll just put REF for reference angle. Okay? So I'm going to have x comma y. Well, for 45 degrees, the x and y are both square root of 2 over 2. Okay? Now, here's the difference, though. For the second quadrant, x is negative, y is positive. Okay? So my x over here is going to be negative. My y is going to stay positive. In case you've forgotten, in the first quadrant, x and y are both positive. In the second quadrant, x is negative, y is positive. The third quadrant, they're both negative. And the fourth quadrant, x is positive, y is negative. So how would we deal with that? Well, that's why my last step that I didn't have enough room to write down, I'll put over here, is put a negative sign where necessary. Put negative where necessary. All right. Now, if my terminal size in the first quadrant, they're both going to be, leave them both positive. if you're in the second quadrant, make the x1 negative. If you're in the third quadrant, make them both negative. If you're in the fourth quadrant, make the y negative. Here I made my x coordinate negative. Okay, so I know x and y. Well, I know that my sign up here is going to be equal to my y coordinate. Well, my y coordinate is just the square root of 2 divided by 2. Okay? How about if we want to find the secant of 5 pi over 4? Okay? So let's look at another one. Say we want to find the secant of, say, 5 pi divided by 4. Now, all we need to do is find x and y. Okay? So again, we're going to do the same thing. First, we want to find out what quadrant we're in. Okay? Well, here is pi over 4 degrees. And here is pi over 4 times 2, which is pi over 2 degrees. And if we go forward, here's a 3 pi over 4. So this is, say, 2 pi over 4, which is just pi over 2. This is going to be another 45 degrees, which is going to be 3 pi divided by 4, right? We go, again, another pi over 4 degrees. This is going to be 4 pi divided by 4, which is just pi, or 180. And we go forward another pi over degrees, and this over here is going to be 5 pi over 4. Okay? So 5 pi over 4 is in the third quadrant, right? So our nearest angle, our nearest side of the x-axis is over here, and it's 4 pi over 4. And I'm gonna leave it as 4 pi over 4. I'm not gonna cancel the 4s and write pi because I want to subtract these two numbers, and right now they have the same denominator. So my second step, so I located the quadrant. My second step was to find my reference angle. So that's going to be this angle right here, okay, between these two guys. So my reference angle is, I'll call it theta, is going to be equal to 5 pi over 4 minus 4 pi divided by 4. So again, I'm going my steps. My first step was find the quadrant. Second step, find the distance between this angle and the angle for the nearest side of the x-axis, which is 5 pi over 4 minus 4 pi over 4, which is going to be equal to, again, absolute value of pi over 4, which is just equal to pi over 4. Okay, and again, I'm just going through the steps because remember, the first step is identify what quadrant we're in. Well, we're in the third quadrant for 5 pi over 4. 4 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. The pi over 4 split the quadrant, so it's like going a half, another half, another half, another half. Right. We stop at 5 pi over 4. So in the third quadrant, my nearest side of the x-axis has an angle of 4 pi over 4, which is 4 pi. And gives me a reference angle if I difference those two of pi over 4. Right? Now, my third step was I write down x and y for my reference angle. Well, since I'm pi over 4, my x comma y is equal to the square root of 2 over 2 and the square root of 2 for both x and y. Now, in the third quadrant, they're both negative, right? Because I'm down and to the left, right? Or if you look over here, just a reference, they're both negative. So I make both x and y negative. And I want to know the secant. Well, I know that this is my x and this is my y. Well, the secant is equal to 1 all over x which is just equal to 1 divided by the negative square root of 2 over 2, which is equal to the negative square root of 2. So the secant of 5 pi over 4 is negative square root of 2 over 2. Okay? Okay. So let's do another example. Let's say we want to find the cosine of, well, we're going to do plenty of examples like this actually. Okay. So let's do one with the, let's try, let's get away from the pi over 4. Let's work with the 30s and the 60s. And suppose what we want to do is we want to find the tangent of 150 degrees. So again, what I'm going to do is I'm going to start out by drawing the unit circle. I'm going to find the tangent of 150 degrees. Well, here's 0 degrees. Here is 90 degrees. Here is 180 degrees. So right away, I know my first step is I locate what quadrant I'm in. And I am right over here. I'm in the second quadrant. I'm past the 90, I'm not up to the 180. Now, in the second quadrant, my nearest, the angle associated with the nearest side of the x-axis, the negative axis in this case, is 180. So my reference angle, I'll call my reference angle theta, is going to be the absolute value of 180 minus 150. It doesn't matter if you do 50 minus 180, you're taking the absolute value. In this case, it gives me a 30-degree angle. Okay, so my second step was find my reference angle. My third step is write down x and y for my reference angle. So x comma y for my reference angle is equal to the square root of 3 over 2, because my x value for 30 degrees is square root of 3 over 2. My y value is 1/2. Okay? Now, my third step is I'm in the second quadrant, so that means I make my x negative, because x is negative in the second quadrant, y is positive. So I do this over here, and the tangent of 150 degrees is equal to y divided by x, which is equal to 1/2 divided by the negative square root of 3 divided by 2. If I multiply top and bottom by 2, the 1/2 cancels with the 2. And I'm equal to a negative 1 all over the square root of 3, which is equal to negative square root of 3 over 3. Okay? All right. And I'm going to do another example from here. Now the next example I'm going to do is just slightly different. I'm going to do a negative. And the negatives work the same way. Suppose I want to find the cosine of negative 60. Okay, negative 60 degrees. Well, remember, for negative angles, we just go clockwise. So that means I'm over here. Here's my 60 degrees, or negative 60 degrees, right? And I'm in the second quadrant.